All right, what we're going to do now is talk about increasing, decreasing, and constant functions. All right, and some of them have all three in one function and so forth there. All right, so let's just look at first this visual, and then I'll come to all this nerdiness over here. All right, so a graph is increasing when when you go from left to right, and it's going up. Kind of makes sense, right? We read from left to right. So when you go from left to right, it's going up. That's increasing. We say that the function is increasing from 2 to 4 because when you read from left to right, the graph is going up. Okay? A graph is decreasing when you go from left to right and it's going down. So from -2 to 0, it would be decreasing. Okay, and actually, let me just write this right here. The way that we write the interval in which something is increasing, it's increasing from the interval of 2. It starts at 2 and it goes all the way up to 4. Now, and anytime that we write our intervals of increasing, decreasing, or constant, we will always use parentheses. Say, why are we always going to use parentheses? Because it wouldn't make sense to use a bracket at 2, because at 2, it's neither increasing or decreasing. That's like what we call a point of change of direction. At 2, it's either going to increase, decrease, or go constant, but it's doing neither. At the exact point 2, it's neither increasing, decreasing, or being constant. It does neither of those. So we do parenthesis to say, well, just to the right of 2, like 2.000000001, now it starts to increase. All right, so we will always use parentheses for when we're dealing with our intervals of increasing, decreasing, and constant. All right, and then right here for decreasing, it's decreasing from -2 all the way down to 0. Okay, so these are just the intervals right here. All right, and lastly, when is it constant? You can just see when it flatlines. I'm just get another cool color here. All right, so this is when it's constant, and that happens when it's from 0 to 2. Okay, so these are the intervals, and you can see the colors right there. So let's do an example now. All right, determine the open intervals on which each function is increasing, decreasing, or constant. All right. So this one may seem a little challenging in itself because it kind of looks like it's constant right here, right? Actually, it does look like it's constant. So, which is why I probably need to just go back real quick to this little nerdiness, okay? If something is increasing, like this, see how it's going up? Then it's increasing on some interval, so from 2 to 4. So from 2 to 4 right here, it's going to be increasing. For some x-coordinate x1 and x2 in the interval implies that x1 must be less than x2, meaning like x1, like our 2, must be less than x2 right there. So isn't it true that if I choose anything in between here from 2 to 4, so like, isn't it true that 2.1 is less than 3.9, meaning I chose a number right here, and then I chose a number right here. So this is like my x1, this is like my x2. Okay, well that implies that if I do f of 2.1, which should be somewhere like right here, that must be less than f of 3.9, which, I mean, if you look at it, see how the y value is bigger? And that's what it literally means. It means if you choose two values within the interval, the lower one should have a lower y value. Okay, and we're going to use that right here for this problem. Okay, this cubic function right here does this little increasing, and it looks like it's increasing the whole time, or maybe it looks like it's flatlining. So what I want to do real quick is if you were to bust out your graphing calculator, and let's just graph this guy real quick and see how this is going to work. Okay, so we're going to do x to the power, not x squared. Let me do that over again. X to the power of 3. Okay, and let's graph this guy. What I want to do right now, let's just zoom in. Okay, let's just zoom in maybe to like Go ahead and press zoom 4, decimal. It just does it for like 4.5 or something like that there, okay? So what I want to do now, let's see what happens to this value. Is it really going to flatline? Like, is this really 0? I mean, maybe it is. Let's just zoom in then. All right, okay, press the zoom button, and then press number 2, and then press enter. Oh man, maybe it does go to 0. Well, let's see. If you press the trace button, and if you just scroll to the left, I want you to notice the y value right here. So it's at negative 1.56, and then go to the left. And then go to the left. And then go to the left. And then left. 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 And then just keep going left. Notice what is happening to the y values. They're getting bigger, or they're actually, well, they're getting smaller because it's going negative. But notice that they're not the same though, right? None of these are the same value every time that you tab over, which is telling us something very important. It's telling us that this is not flatlining. This is actually not flat. And you can even zoom in even more. So really, this graph right here, it actually increases the entire interval. The entire interval, like it's increasing. So what we would say, we would just go ahead and put the word increase. Actually, maybe like we'll just say like increasing. What interval is this increasing? Well, this thing goes forever to the left. This thing goes forever to the right. So it's going to increase from negative infinity to positive infinity. I guess this one's kind of weird because this thing, like, it looks like it flatlines. So we had to do a little investigation with the calculator there. But watch, this next one will be maybe much more clear for us. And we want to go ahead and see when is it increasing. When is it decreasing? Okay, so it is increasing. Check this out. See how this thing goes down right here? So we assume that like this is going to go down forever, and this is going to go up forever. So when I go from left to right, it's going to start from way down here. It's going to go up and 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 up. So it's going to increase from negative infinity to negative 1. You see, because look at we're looking at the x values. Maybe you have to make that clear here. When we're trying to find the intervals when our function is increasing or decreasing, we're only looking at the x intervals, the x-axis. So from negative infinity to the x value to negative 1, it's increasing. And then look right here, skip over to 1 right here. See right here, it goes from here and then it goes up. So and then you're going to say union. So we're going to pull these two answers together. It starts back up at 1 again, and then it's going to go to infinity. Okay, so it's increasing here, and then it's increasing right there. Erase that little guy right there. All right, and then it's going to be decreasing. Check this out. It decreases from negative 1 to 1. So it's going to decrease from negative 1 to 1. Again, notice that we don't use any brackets. They're always going to be using parentheses. Okay, and let's come down here to this last one. So we can see here it's increasing right here, constant, and then it's decreasing. So let's go ahead and write down those 3 intervals. Okay, so it's increasing from negative infinity because it starts way down over here, and then it goes up and 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 up, bing. So it's going to increase from negative infinity to 0, starting way down here to 0. Again, looking at the x-axis, and then it's going to be constant. It's going to be constant from 0 to 2. Only use the x-axis, and then it's going to decrease from 2 to negative, 2 to positive infinity. From 2 right here, and then it's going to keep going to the right, forever.